Hello, my name is Gary Lee and welcome again to Racing Against Time, a look at the Wristwatch Revolution 1957 to 1982. In this second episode we look at the basics of timekeeping and do a bit of jargon busting. More specifically, we look at what timepieces are, learn to identify different types of wristwatch movement, look at the pros and cons of movement types, deal with some words and phrases used about wristwatches, and finally look at more of the challenges of designing and making wristwatches. Timepieces. This term generically refers to watches, clocks and other timekeeping devices. Wristwatches are a subset of watches, watches are a subset of timepieces. Simple enough so far. But what exactly is a timepiece? The common sense answer, something that tells me the time, is sort of right. But then, as we saw in episode 1, so many other things tell us the time these days as well. Tablets, laptops, phones. First of all then, we can think about something that specifically does the job of telling the time. Second, we can also think about something that does not need to be connected to a network in order to do the job. Ultimately though, in order to define timepiece better, we need to go deeper, and warning, this is not entirely intuitive, but please bear with me as I explain. So a timepiece then is a powered device that counts the beats from an oscillator and displays that count in a specified time format. To make things simpler, let's break that down a bit into parts, focusing on the underlined words and phrases. For any timepiece that works standalone at least some of the time, we need 4 basic building blocks. We need a power source, provides energy to power the device. We need an oscillator, something that provides a steady, reliable beat. We need a counter that counts that steady, reliable beat. And we need a display that puts the beat count up in a specified time format. Now, each one of those building blocks, depending on the design, can be mechanical, electrical, stroke electronic, or a hybrid. So here is our first jargon bust. Movement. The word movement in relation to watches refers to the first 3 blocks: power source, oscillator, counter, and are effectively the working guts of a timepiece. It excludes replaceable power cells if they're used, it excludes the display, and it excludes any external casing. Sometimes in relation to timepieces built electronically across all 4 blocks, including the display, a whole electronic timepiece, you'll see the word modules used instead, and this was imported sideways from the electronics industry in the 1970s. So now, focusing back in on wristwatches, we can start to break down different kinds of movement into those 4 basic building blocks in order to understand them. To start this, let's take a typical basic mechanical movement. Don't worry if you can't quite visualize what I'm saying initially, because there will be a video that comes up in the following slide. Alright, for our basic mechanical wristwatch, the power source is a coiled spring called the mainspring, held in a geared toothed enclosure called a barrel. The mainspring can be tensioned by winding up, either manually using the crown, an exterior protrusion that also does time-day date adjustment, or automatically on a wristwatch where the movement of the wearer causes a weighted rotor to move around inside the case of the watch. Once the energy is stored in the mainspring, it's then transferred through the wristwatch's gear train, known as a wheel train, into the other blocks. The oscillator in a mechanical watch typically is a balance wheel and a balance spring, sometimes called a hairspring because of its hair-like fineness. This swings one direction and then, under the tension being released, back the other, quite visibly if you've ever taken the back off of a mechanical wristwatch. The front end of the counter is the escapement, and this is the part of the wristwatch that actually ticks. It's usually made up of a snaggle-toothed escape wheel and a lever with a fork and pads called pallets. The rear end of the counter is a series of wheels and so-called reduction gears that turn each of the different hands at different speeds. That leaves display, and that's just the dial and the hands, typically in a 12-hour AM/PM plus 60-minute plus 60-second format. Okay, now this sounds complicated, but let's look at the following video where a watch mechanism is displayed in a line courtesy of a researcher at Milan Polytechnic and Wiki Commons. Now I'll run the video, sit back and enjoy. Other movement types in chronological order of development are the electric and electronic balance types, the tuning fork type, and the quartz type. Quartz is not only very accurate but very flexible in that it can have a display block with traditional hands and dials, a so-called analog display. It can have a digital or alphanumeric display block using light-emitting diodes or liquid crystal displays, or even some kind of combination. We will look at these other movements in later episodes, but before we do, we have to consider a fundamental dispute between a small but vocal minority of collectors that love quartz watches versus a larger group of collectors that dislike them and or collect only mechanicals. One key part of the wristwatch revolution I will cover in this series is the emergence of the quartz wristwatch in the late 1960s. Like them or hate them, quartz wristwatches are much more accurate than mechanical ones. Their accuracy measurable in seconds per month or even seconds per year, rather than seconds per day as with most mechanicals. Given this, if wristwatch buying were dictated solely by accuracy alone, they should have died out sometime in the 1980s. And yet mechanical watchmaking not only recovered, but survived and thrived. Today it's in rude health. Why? The answer lies in industry restructuring that occurred as the result of the wristwatch revolution we're looking at, something I cover with my company reviews of the Super 6. That restructuring resulted in a shift up market in mechanical watchmaking. Many models and brands, particularly from Switzerland and to a larger extent in the US, disappeared from the 1970s onwards, with the survivors redeveloped as either luxury goods or at the very pinnacle, so-called haute horlogerie. Like haute couture in the clothing world, haute horlogerie signals an ultra-exclusive, craft-centric approach, with small production runs and limited editions, significant hand build and finish, exotic designer materials, all with big price tags to match. In short, since the 1980s, mechanical wristwatches have been subtly but powerfully remodeled as high-status symbols, as a look at any financial journal or luxury goods journal will attest. From my own point of view, I say that quartz versus mechanical does not have to be a thing. First of all, if you like luxury on a budget, there are plenty of excellent vintage mechanical wristwatches to choose from. Second, even if typically less accurate than quartz, mechanical wristwatches do have at least two practical advantages over most of their quartz cousins. One is that there are no power cells to worry about, replacement leakage issues, something like that. The other is the combined effect of build longevity and greater availability of spares and servicing. Many mechanical wristwatches of over a century old are still working happily, whereas the majority of quartz watches over a decade old are not. But remember that there are hidden cons, the bear traps, with mechanicals as well. Although notionally easier to maintain, keeping mechanical wristwatches going can be just as expensive as keeping high-performance vehicles on the road, and for exactly the same reasons. Wear and tear on parts, plus the need for proper, regular servicing and lubrication by experts in the field. So ultimately, I'm neutral. I appreciate design and excellence in any kind of movement, any kind of module. Okay, jargon time. We've already looked at a few terms for movements and their parts, and modules, and so on. Here's some of the important words and phrases you'll meet along the way. Bezel, a ring around the dial and crystal of the watch, sometimes functional, sometimes decorative. Bridge, a plate or bar attached to the main plate of the movement, forming part of the frame for the moving parts. Caliber, spelling may vary depending on where you are in the world. A term borrowed from gunsmithing in the early 18th century. It refers to particular types, sizes and models of movement, still sometimes measured in linear, though more often today in millimetres. Caseback, the rear cover of a wristwatch, sometimes has a transparent viewing port. Chronograph, a wristwatch or other timepiece that has stopwatch functions. Chronometer, a timepiece certified to specified accuracy and precision by a recognised certification body. Since the 1980s, the term chronometer by default refers to timepieces certified by the Swiss Chronometer Testing Institute, COSC. An important point here, do not confuse chronographs and chronometers. Some chronographs are chronometers, but not all are. Complication. Any mechanism or function that goes beyond telling the time in hours and minutes. So complications will include day date, stopwatch, moon phase, alarms and similar. Crystal. The transparent cover over the dial. Although called a crystal, it can be made from any material, from acrylic plastics to mineral glass to the latest synthetic sapphire glasses. Deployment clasp. Sometimes incorrectly called a deployment clasp, it refers to a fold-over and self-lock clasp on a watch strap or watch bracelet, in place of a traditional buckle arrangement. Dial, proper term for a mechanical display background instead of the more often used face. Frequency, the rate at which the oscillator beats, can be measured in hertz, beats or vibrations per second, or beats or vibrations per hour. Gasket, seals used to exclude dirt, moisture and other contaminants. Inca block, one of a number of movement shock protection systems developed from the 1930s onwards. Indices, markers used in place of numbers on a dial. Jewels, sapphires or rubies used as bearings and pads in watches. Important note, these are small and since the early 20th century mostly synthetic. So although technically important, they are not particularly valuable, and more does not necessarily mean better. As a rough rule of thumb, any count over 41 is unlikely to be load-bearing, even in a chronograph or other watch with complications. Lugs, the arms that stick out from a wristwatch case and retain the strap or bracelet via a fixed bar or a spring bar. Pusher, a button for starting, stopping a complication function on a wristwatch, such as seconds timing on a chronograph. Tourbillon, a kind of movement with a caging system for a balance spring to reduce the effect of motion and gravity. Complex to build, a real demonstration of the watchmaker's art, and correspondingly expensive. Often paired with skeletonized movements and transparent case backs, so you can see the work done. Finally today, a quick reminder of the challenges of designing and building wristwatches. We've already looked at one part of the problem, the micro-miniaturization of parts. The other is the hostile environment in which that assembly of tiny, delicate parts has to work. Wristwatches have to cope with changes in temperature. These can affect not only the metals of cases and other components through expansion or contraction, but even the rates of quartz oscillation. They have to keep out dirt, dust and other debris. They have to resist water, moisture, salts, from anything from the sea to your sweat. They have to resist shock, vibration and positional gravity effects. They have to resist electrical discharges and magnetic fields. In fact, when you look at wristwatches and what they have to endure, it's amazing that they ever work at all. Well, that's all for this time. Next time we move on to the first of our company and product histories, starting with the Hamilton Watch Company. The US company that moved us from the mechanical watch to the electrical watch. Thank you very much. Goodbye for now.